Have you been feeling sick lately? Do you think you have a relatively weak immune system? Well, we might just have an answer for you. Hi, we are from Green Pulse and we are proposing to you our 100% pure organic chlorella tablet. So, what is chlorella anyways? Well, Chlorella vulgaris is a species of microalgae that is valued for its nutritional benefits, particularly its high protein content, essential fatty acids, vitamins, and antioxidants. Therefore, you can find them as supplements. After a thorough market research, it is found out that Chlorella vulgaris was valued at 251 million US dollars in 2022 and they gradually increased within the years. In Malaysia, they approximately cost 248 ringgit per kilogram in enriched live food command market. And then per annum, they could cost up to 259 million ringgit in the context of tilapia farming. So before we start our whole research activities, we have listed the three problems that became the baseline of our project. The first one being what is the optimal temperature for maximizing the growth rate of Chlorella vulgaris. The second one is which growth medium provides the best conditions for the proliferation of Chlorella vulgaris. And the last one being what is the most appropriate pH for cultivating Chlorella vulgaris. Moving on, according to those three problem statements, we have come up with these three hypotheses. The first one is that the temperature of the Chlorella vulgaris is optimal if it's 20 to 30 degrees Celsius. The second one is that the best growth medium for Chlorella vulgaris is bold Bassel medium. And the last one, as for the optimal pH value for the growth of Chlorella vulgaris, is between 6.5 and 8.0.
So next, we move to the research question. For the first research question is, what is the optimal temperature for Chlorella vulgaris to grow in? Second, what growth medium is the best for the cultivation of Chlorella vulgaris? Next, what is the appropriate pH in order to cultivate Chlorella vulgaris? For the objective of the research are to identify the optimal temperature for Chlorella vulgaris to grow in. Next, to identify the best growth medium for Chlorella vulgaris. Lastly, to determine the right pH for the cultivation of Chlorella vulgaris.
It can be seen by the literature review that we have studied that the optimal growth parameter included in three sections, which is the temperature, growth medium, and pH. The temperature for the cultivating Chlorella vulgaris is optimal at range of 20 to 30 degrees Celsius, and bulk medium with vitamins and soil extract is the best growth medium with the pH 6.5 to 7.5.
Next, for research activities, the objective to achieve is optimal temperature for Chlorella vulgaris to grow in. There are several methods to do in achieve this objective. First, choose a range of temperature to test, ensuring it includes both lower and higher extremes where Chlorella vulgaris might grow, which are 15 degrees Celsius to 35 degrees Celsius in 2 until 3 degrees Celsius increment. Next, maintain a control group at the non-optimal temperature for Chlorella vulgaris growth, such as 26 degrees Celsius without changing the temperature because this is the baseline to compare the effects of other temperatures. Next, use a standardized growth medium such as BG11 or another suitable medium to ensure that all cultures have the same nutrient availability. Next, maintain other growth conditions such as light intensity, pH, nutrient concentration, and make it all constant across experiment to isolate the effect of temperature. Next, inoculate the medium with a specified concentration of Chlorella vulgaris cell to provide consistent starting condition across all the samples. In addition, use incubators or temperature control to precisely maintain the required temperature in each experimental group. Moreover, regularly monitor and record actual temperatures to maintain accuracy. And lastly, measure growth rate using methods such as optical density at 60-100 nanometer to cell count using to count the cell using a flow cytometer for direct cell count or biomass dry weight at regular intervals such as daily or every few days. Okay, next, to achieve the second objective, which is best growth medium for Chlorella vulgaris, we need to do several methods. The first one is choose a variety of growth media to test, such as BG11, Ball Basel, Bristol medium, triacetate phosphate medium, and Chu-10 medium. All of these medium we use to test the growth of Chlorella vulgaris in this media. Next, maintain a control group using a standard medium known to support optimal growth of Chlorella vulgaris such as BG11. This control group serves as a baseline to compare growth performance with experimental media. Next, prepare each growth medium according to standardized technique to ensure consistency and sterilize all media to prevent contamination. All the media should be labeled clearly to avoid the mix-up. In addition, standardize the initial cell density of Chlorella vulgaris across all the media. You can use a flow cytometer to accurately count cells and prepare inoculums of equal concentration for each medium. Next, maintain identical environmental conditions such as light intensity, photoperiod, pH, and aeration for all cultures to isolate the effect of the medium. Lastly, measure growth parameter regularly such as you can measure daily or a few days using multiple method which is optical density, cell counting using flow cytometer or biomass measurement. Calculate and compare growth rate at different media. Use statistical method to identify the best media with the highest growth rate to consider any significant measurement. Lastly, for the research activities, we need to find the right pH for cultivation of Chlorella vulgaris. We need to do several methods such as before inoculating of Chlorella vulgaris, measure and record the pH of each growth medium in the BG11 or bulb basal medium using a calibrated pH meter. Ensure all initial pH measurements are within a predefined optimal range such as 6.5 until 7.5 because this is the optimal pH to growth Chlorella vulgaris. Regularly monitor pH levels throughout the experiment. You can ideally daily or depend on the pH stability of the medium and growth condition. Next, prepare standardized solution of acid such as hydrochloric acid and base such as sodium hydroxide for pH adjustment. If pH is too low, which is acidic, add small amount of sodium hydroxide while monitoring pH continuously. While if the pH is too high, which is alkaline, add small amount of hydrochloric acid while monitoring pH continuously. Maintain a control group where pH is kept stable within the optimal range throughout the experiment without adjustment. Regularly check and adjust nutrient concentration to maintain a balanced medium as nutrient imbalance can influence pH stability. You can use precise carbon dioxide supplementation methods, which is bubbling CO2 gas, to maintain consistent level and minimize pH fluctuations. Repeat the experiment, especially around critical pH range, to validate the effects of pH management on Chlorella vulgaris growth. Lastly, compare results with control groups to verify the impact of pH on growth parameters.
Now let's take a look at the methodology flow for finding the optimal temperature for Chlorella vulgaris to grow in. Firstly, 3 ppm growth medium was prepared and then the medium was then inoculated with Chlorella vulgaris. The inoculated medium were then placed in different rooms with different temperatures. Other conditions such as pH and light intensity were maintained constantly. After 20 weeks, each culture were retrieved for true analyzation. A cytometer was used to count the cells in each culture and then the results were compared. Continuing to the methodology flow for finding the best growth medium of Chlorella vulgaris, All apparatus was first sterilized before using. Tree growth medium was prepared, which was BG11, Bristol medium, triacetate phosphate medium, and True 10 medium. And then each media was then labeled clearly. A flow cytometer was used to count cells accurately. The initial cell density was standardized across all media. Inoculums of equal concentration was prepared for each medium. Parameters such as pH, temperature, and light intensity was kept constant. And finally, the growth rate was then compared after 20 weeks. Finally comes the methodology flow for finding the right pH value for the cultivation of Chlorella vulgaris. Firstly, the pH of the culture medium was monitored. If it's too acidic, a base such as sodium hydroxide is used. If it's too basic, an acid such as hydrochloric acid is used to treat it. Then it is ensured that the nutrient medium was using BG11 and F per 2 medium, and then dissolve carbon dioxide in water to form carbonic acid as a buffer and an additional carbon source for the algae. And finally, the pH levels are regularly checked using pH meter.
So this is the schematic of lab that we have done. We use the application 3D Designer West Lab software. As you can see here, we have two rooms divided, and the first one we have for the culturing of the algae that we have laminar flow, grinding machine, autoclave, vacuum sealer, heat sealer, and the next room we also have microscope, air conditioner, centrifuge, lyophilizer, label printer, and printer. These are the equipments needed in our lab to culture the Chlorella vulgaris. Here is the front view of the schematic of lab, and the left view of the first room, and the right view from the second room.
Next, we move to the harvesting. Actually, what is the best timing to harvest Chlorella vulgaris? As I found out from the research and the journal, the best timing to harvest Chlorella vulgaris is at the exponential growth phase. In our experiment, we choose centrifugation method to harvest the Chlorella vulgaris. Firstly, you distribute the culture into tube, which is as you can see at the right of the screen. The centrifuge tube you can fill up to 70 until 80%, and all the tube have the same volumes. Next, adjust the centrifuge machine speed to 3000 to 5000 rpm for 10 until 20 minutes and start the centrifuge and monitor for smooth operation. For the post-centrifugation, let the centrifuge machine stop completely before you open and remove the tubes carefully from the machine. For the collecting biomass, carefully pull off the supernatant without disturbing the pellet. If you know, the supernatant is the liquid at the centrifuge tube and the pellet is the culture at the lower of the centrifuge tubes. And for the post-harvest processing, use a freeze dryer to produce chlorella powder and press the dried powder into tablet using a press machine. Next, we move to the section of packaging product. We start with the logo of our company. This is the logo. Our company name is Green Pulse and our tagline is Green Energy Pure Vitality. Okay, so this is our packaging product. At the left of your screen is the front view and at the right of your screen is the back view. As you can see at the front of the view, we have airtight seal of packaging and there is a logo and name of product which is organic chlorella tablet. And for the type of packaging, we choose Mylar bags because it's provide excellent protection against light. And Mylar bags also effective at blocking moisture, which is essential for maintaining the quality of the tablet, since exposure to moisture can lead to microbial growth and degradation of the active ingredients. Mylar bags also offer an optimal barrier against oxygen in preventing oxidation of the nutrient and active compounds. At the right of your screen have a back view which is we have the logo of our company, nutrition facts and the ingredients. We also have the suggested used for daily and for the in our packaging product we have 400 tablets with 250 mg. Why we choose tablets? Because it easy to consume more than powder form and it 100% pure chlorella vulgaris, and it's good for your overall health. The suggested daily use is 4 until 6 tablets per day. Next, for data analysis, the objective to achieve is to identify the optimal temperature for chlorella vulgaris to grow in. As we can see at the result, the highest net specific growth rate was observed at 25 degrees Celsius. The growth rate decreased significantly at temperatures above 25 degrees Celsius, with a sharp decline note between 25 degrees Celsius and 30 degrees Celsius. So we can assume that the optimal growth temperature for the chlorella vulgaris strain in the photobioreactor was estimated at 25 degrees Celsius, and the mortality rates increased significantly between 20 degrees Celsius and 28 degrees Celsius. We analyzed the data by plotting growth curve for each temperature, calculating the specific growth rate, and comparing the maximum OD readings, which is optical readings, using statistical analysis such as ANOVA, and it can determine if the difference in growth are significant. Next, we do the data analysis to determine the right pH for the cultivation of chlorella vulgaris, and at the end of the result, Bol basil has the highest optical density reading, which is 3.389, and which with the growth rate of 0.278 per day. The nutrient deficiencies in media will impact on growth and optical density. In the Bol basil, the nutrient is complete with nitrogen, phosphorus, iron, and magnesium. The importance of balanced nutrient composition for maximizing chlorella vulgaris growth. We also plot growth curves for each medium and calculate specific growth rate. Perform statistical analysis such as ANOVA to determine if differences in growth are significant. And as you can as we observe, the Bol basil are the best growth medium for chlorella vulgaris. To determine the right pH for the cultivation of chlorella vulgaris, we do some data analysis, and we found out that optimal pH for chlorella vulgaris growth and biomass production was at 6.5. The highest optical density or D readings were recorded, indicating robust growth. And we determined using a spectrophotometer Spectronic 721 model set at 670 nanometer. Growth production is significantly declined as pH level becomes more alkaline, which is 8.5 and above.
So the duration of our research was 6 months, starting from March 2024 and ending at September 2024. And the location of our research was at the laboratory of Department of Biology, Faculty of Science, UPM. So these are the milestones and dates of our research project. As you can see in the initial part of the research, we had an acclimatization of algae in lab flask, which took us a month before starting a field culture setup, cycle 1. So in total, we have 5 cycles because we are trying to maximize the production of our chlorella. And then the harvesting of algae took around a week, and finally post-harvest processing, which is the packaging part, took us around a week as well. So this is the Gantt chart of our research, which has included our milestones from the chemical preparation and lab setup towards the post-harvest processing, which is the packaging part. So this is just to give you a better visualization of what we have achieved in a certain period of time.
So for the budget, we divided into 4 sections, and the first one is salary. We paid lab technician 1,500 ringgit for 12 months. For the second section, we have the chemical section where we included all of the chemicals we needed to culture and produce chlorella vulgaris supplements. As you can see here, we have BGY11 medium, sodium bicarbonate, manganese sulfate, zinc sulfate, and also liquid nitrogen. Next, we have equipments needed such as beakers, flasks, pipettes, autoclave, table press machine, orbiter shaker, and fluorescent lamp. These are all the equipments needed for our lab. Next, in our budget listing, we have the disposables part, which includes such as safety goggles, markers, petri dish, filter paper, mylar bags, and also silica gel packets. Last but not least, we use the professional services or consultancy, and we have some of the consultancy included packaging technology, drying techniques, sour disruption, experimental design, and statistical analysis. The budget that we use for a year is 136,215 ringgit Malaysia. So for the return of investment, we sold 2,000 packets of Chlorella vulgaris supplements with 100 ringgit for each bag. Minus with the budget and divide with the budget, we had 46.8% positive profit for the return of investment in a year.